What up, peeps? All right, so again, this is lesson 2.2. We're going to start with a little warm up. We need to graph the inequalities. Z is less than or equal to 5, negative 2 is less than W. Go ahead and try to graph those, and then we'll go over them. All right, so when we're looking at V is less than or equal to 5, all we got to do is draw our nice little number line. Here's 0, here's negative 1, here's 1, 2, 3, 4, 5, and we'll go to 6. At 5, guess what? It's a closed dot because it's got this line underneath. So we're going to close our dot at 5, and Z is less than or equal to 5. So we are going to be shading to the left. So all this gets shaded in. I'm going to make this nice and shaded. And that is our answer. So that was 30. And then 32, we're also going to draw a number line. Here's 0, here's negative 1, here's negative 2, here's negative 3, here's 1, here's 2. We are going to put an open dot at negative 2. Why is it open? Because it is less than, not less than or equal to. And for those of you that like to rewrite this, this is the same as W is greater than negative 2. You can flip it. And as I see, my arrow is pointing to the right. W needs to be greater than, so we need to shade the area to the right. So we're shading to the right, and it continues on forever to the right. Okay, so Z can be everything greater than negative 2. I'm sorry, W can be anything greater than negative 2. Can W be negative 2 though? Absolutely not, okay? It would need to have that little line underneath in order for it to be equal to the value. All right, cool beans. Continues on. Okay, chapter 2, solving linear inequalities. This is lesson 2.2, solving inequalities using addition or subtraction. So we talked about inequalities, what they are, how they're useful, all that stuff. Okay, again, I apologize for not being able to be there today, but this lesson, to be honest, is going to be a breeze. Okay, because we all know how to solve equations, and we solve inequalities the exact same way. Ooh. Our objectives, again, do not copy this down. We need to solve inequalities using addition, solve inequalities using subtraction, and use inequalities to solve real-life problems. If addition and subtraction were babies, addition would be the baby that everyone loves. It's giggling, it's happy, okay? We all know how to add, and then subtraction can kick our butt sometimes. It's annoying, it starts to scream, and we don't particularly like it, okay? All right, how does this apply to me? How am I ever going to use this? So inequalities are great for setting up restrictions on a maximum and minimum value. Today, we're going to discuss, once you have set one up, how do you solve for the value that you're trying to find? And then check out the word problems at the end for some real life examples of inequalities at work. We also have 2 homework problems that involve word problems. And again, we're still talking about inequalities, so this same list of professions that use these inequalities still apply, okay? So we're shading. All right, so let's graph an inequality using addition. Let's solve an inequality using addition, and we're going to solve and graph it. So make sure that you copy down this entire sentence. Solve x minus 6 is less than or equal to negative 10, and then graph your solution. So guys, when we're solving these, okay, the inequality, which says greater than or equal to, we are going to treat this just like an equal sign. Okay. Now, it doesn't mean it has the same properties as an equal sign. We're just going to treat it like an equal sign, so we're going to move things around it. We're going to, in that regard, okay? So, in our inequality, what's our variable? Our variable is x, and then we solve it the exact same way. So we're trying to get x by itself, since it started on the left side of that equation. Or I'm sorry, this inequality. Now, I see that there is a minus 6 here. And guess what? We're solving inequalities using addition. So guess what we do? We add 6 to both sides. So I'm going to rewrite this as x minus 6 is greater than or equal to negative 10, just so we can do plus 6 to both sides. And we've got x, because these go away, is greater than or equal to negative 4. Negative 10 plus 6, the negative 10 is the bigger number. So we've got negative 4 as our answer. Okay, and let's go ahead and graph it. We draw a nice little number line. Here is 0. Here's negative 1, negative 2, negative 3, negative 4. We put a closed dot at negative 4, and x is bigger than or equal to, see daisies, we're shading to the right. To the right, people. To the right, to the right. I'm just kidding. Beyonce's song is to the left, people. Okay, so we shaded to the right, and we are Gucci Marucci. All right? That should have been pretty standard, okay? We treated the inequality just like an equal sign, and we solved this inequality using addition, okay? Keep happening to me. Let's see solving inequalities using subtraction. So let's go ahead and solve each inequality, and then we're going to graph the solution. So let's start with A. Get these copied down. Y plus 8 is less than or equal to 5. And guess what we do here? Well, I notice my variable is now y. Y is still on the left side of the inequality, so we're gonna subtract 8. We want to move that 8 out of there. Once we subtract from one side, same thing applies with inequalities. We have to subtract from the other side. So we're going to subtract 8 from both sides. These are going to cancel, and you're going to get y is less than or equal to, now 5 minus 8, people, is negative 3, okay? If you were on that track, awesome. If you're still having troubles with that subtraction stuff, just remember, find whatever value is bigger, the 8 is bigger, and that whatever sign that was, that's going to take over. So we know that our answer is going to be negative. We subtract them because the 5 was positive and the 8 was negative. When they have different signs, we take their difference. All right, cool beans. So we've got y is less than or equal to negative 3. Let's draw a nice little number line. 0, negative 1, negative 2, negative 3. At negative 3, it's going to be a closed dot because it is less than or equal to, and we are going to be shading to the left. A la izquierda, to the left. And this is our shaded arrow. If you wanted to test it out, let's plug in negative 4. Is negative 4 less than or equal to negative 3? Booyah. Okay, we shaded the right region. Okay, B, we've got negative 8 is less than 1.4 plus m. So what we're going to do here is we're going to do the exact same thing, but our variable is m, and now it's on the right side. Does this change anything other than working with the right side? Absolutely not, people. Okay, same exact process applies. So how do we get that 1.4 out of there? Well, the operation that's going on between the 1.4 and the m is addition, and the 1.4 is positive. So guess what? We got to subtract it. We're going to take away 1.4 from both sides. And once we do that, peeps, we're going to get negative 9.4 because they're both negative, so we add them. See that, peeps? These are going to go away, and we've got m. So we know m needs to be bigger, or negative 9.4 is less than m. So we're going to draw our nice, fashionable number line. Here's 0, and we have to go all the way to negative 9.4, okay? I'm not going to do it exactly. Let's go negative 5. This is negative 10. So this will be negative 9.4. Something like that, okay? Open or close circle. Well, it is less than. So open circle here. And then we're shading to the right because m has to be bigger. Now, those of you that like to use the method where you look for the arrowhead, okay? You can't use it right now because m is on the right side. So you're just going to have to flip everything. So flip these two and change your inequality sign. So m greater than negative 9.4. Now we know we're shading to the right because our arrowhead is pointing to the right, okay? So we're just going to shade to the right. Again, guys, if you understand this without rewriting it, don't rewrite it. It's just a recommendation. If you can't figure out which side of the number line to shade, okay, flipping it around sometimes helps, right? If your friend that's sitting next to you knows a better method, ask them, listen to them, okay? But only if you're not getting it. If you're getting all of these 100% right, there's no need to change anything, peeps. You're golden. Okay. Hopefully we don't have too many questions on what we're doing, okay? This is basically one-step equations, but instead of an equation, it's an inequality, okay? But remember, we treat those inequality signs the same way we treated the equal signs. Okay, moving on. Last slide, people. We're almost there. Do you have to copy down this entire word problem? Yes. Unfortunately, this is the only way it'll go into your notes, so you need to copy down this entire word problem. If you guys want to pause the video so you guys can copy this and then listen to my beautiful voice, that is perfectly fine, okay? So whoever's in charge of, or whoever's near the TV, just pause it, and then you guys can copy it down, and then play it once everyone's done. Okay, a circuit overloads at 1,800 watts of electricity. You plug a microwave oven that uses 1,100 watts of electricity into the circuit. Part A, write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit, okay? All right, so first thing that we do for pretty much any problem is we want to underline the things that are very, very important to us. We are given that the microwave holds 1,800 watts of electricity. Our microwave oven that we just plugged in takes up 1,100 watts of electricity of that circuit, okay? So we take 1,800 and we've got 1,100 used. We need to solve an inequality that represents how many watts you can add, okay, to the circuit without overloading the circuit. This is going to be our variable. And you could have picked any letter. I'm going to pick W for watts, okay? So W is going to represent the amount of watts you can add. Okay? Now, W plus 1,100 needs to be less than 1,800. Okay? How on earth did Mr. Yurko come up with that? Well, this is our total, agreed? We can't go over that value. That is the maximum, okay? So our caret needs to open up towards the 1,800. 1,800 needs to be the maximum. If we went over, we would blow the circuit. Everything would go to cahoots, okay? A circuit overloads at 1,800 watts of electricity. Can we be at 1,800 watts? No. Do not put equal sign, okay? It overloads at that watts of electricity. So don't go over it. So this is our inequality. Now, the second part of this question said to solve it. So let's go ahead and solve it. I'm going to rewrite it down here so we can solve it together. W plus 1,100 is less than 1,800. Guess what, peeps? What operation do you think we're going to use to solve this? Well, W's on the left, boom, and there's that 1,100 next to it. Guess what we do? We subtract 1,100. Oops, if I could write, 1,100 from both sides. Booyah. These cancel. We're going to get W alone is less than, I think this is 700. Yeah, 700. Wow, people. We just found the amount of watts we can add needs to be less than 700. Now, some of you are like, oh, Mr. Yurko, I knew this just by looking at this problem. Guess what, people? If you were to just write 700 you are not getting this question correctly. You need to write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. I saw in a lot of our quizzes, people are like refusing to do the extra step, and you're losing points for it, okay? So, in addition to the microwave oven, which of the following appliances can you plug into the circuit at the same time without overloading the circuit, okay? So you should already have this table written down. If you don't, pause the video, copy it down if you didn't realize that you had to copy it down, okay? And we've got appliance and watts. We're gonna put a check mark if you can add that. Is a clock radio okay to plug in? Well, we have 50. Is 50 less than 700? Boom, it sure is. Can we plug in the blender? Is the blender less than 700? It sure is. Can we plug in a hot plate at 1200? Is 1200 less than 700? No, you cannot plug in the hot plate. That will overload your circuit. What about a toaster? Is it less than 700? Absolutely not, okay? So the only two things you could plug in with that microwave oven would be a clock radio or a blender, okay? Guys, this is the end of the lesson, okay? Pretty short, pretty sweet. We got through it. Good job. So what I want you guys to do right now is take pictures of your notes, submit them to the assignment, okay? And our last, by this word problem, okay? Slide is your homework, okay? Guys, you're doing 1 through 23 odd, and then you're also doing number 24 and number 25. Those last two problems, peeps, are the ones that are for homework, okay? I'm sorry, it's all for homework. What am I saying? Those are the two word problems, okay? If you are completely thrown, just do your best. Reference your notes, the one that we just worked on, and see if you can't figure it out, or at least start to figure it out, okay? I need to see an honest attempt on each of those problems. Otherwise, you're not getting the points, okay? All right, I miss you guys a lot. I will be back on Tuesday to give you your test. Dun, dun, dun. No, I'm just kidding. But good luck with everything. Guys, I'm available via email if you guys have any questions. Yeah, I will see you on Tuesday. Good luck with everything. Bye.